Hello. I am here. Uh, just finishing up some video games on my actual computer. Hopefully no visitors this round. Otherwise I gotta figure out how to make a private stream. Yeah, volume's working. Cool. Hi, Matthew. Wrong Rubenstein. Well, it is 7 o'clock, so I guess I'll get started. I kind of wanted to run through real quick while I wait for questions and stuff. Some like the basic ideas and concepts of this unit, just one by one, really briefly. Just to kind of talk about all the stuff that is going to be focused on. Uh, First thing, we took the derivative of natural logs, and that was a pretty tough derivative. It was just 1 over x, which allowed us to graduate onto harder problems like natural log of the 7th root of x cubed over x plus 1. And we used our log rules to pull this thing apart. We could take out the 7th root as a 1/7 natural log of x cubed over x plus 1. And then we could split this to 2 natural logs, one of which is 1/7 natural log of x cubed, and the other one we subtract because we split up the division on the inside into subtraction on the outside as 1/7 natural log of x plus 1. We can even go a step further and take this 3 out of the power and put it as a coefficient here. And then we were cleanly back to where we started with 3/7 times 1 over x for the derivative of natural log of x minus 1/7 times 1 over x plus 1. And that was natural log derivatives. Then, what was our next thing? Oh, integrating natural log stuff. So you had to recognize that anytime you have a 1 over x situation, you're going to be integrating to a natural log of the absolute value of x plus 1. The absolute value being there because this allows us to plug in any x, but if we just had a normal natural log, we can only plug in positive values. So we need the absolute value to get all of the values. And then we graduated on to trickier problems like e to the x over e to the x plus 13 dx, where we can see here that the derivative of the bottom is the top, which makes this a much easier integral if we make the bottom u. Then our du is just e to the x dx, which is exactly my top, and I can rewrite this as du over u, which integrates to natural log of the absolute value of u plus c. And then we just chuck a u back in there, natural log of the absolute value of e to the x plus 13 plus c. And that is how we integrated to natural logs. The next little mini section was logarithmic differentiation. I'm just going to do a quick one of those. If we had like 2x to the 7x power, and we wanted to take the derivative of this, step 1 would be to natural log both sides, which allows us to pull down the power. So yeah, when I natural log both sides, I get to pull the power down, which is the entire point of it. And then the derivative of the left is always 1 over y dy dx. And the derivative of the right almost always has product rule in it. So we have to do a prime times b plus a times b prime, which in this case would be 2 over 2x for du over u. Now that we have this done, all we do is multiply y to the other side, and we're done. So we get 2x to the 7x, which was my original y. And I just multiply by this stuff. 7 natural log of 2x plus, those cancel, those can't, oh, 7. Cool. All right, next concept. Long division integrals. So if you have some janky thing like, what do we use long division for? Something like this. The play here is not to try to do U-sub or inverse trig or any of those other horrible things. The play here is to, I'm going to do synthetic real quick. We drop down a number, we multiply, we drop down, add. We multiply, we add, we multiply. This is a very boring one, and add. And we get a remainder, which usually sucks, but it does not suck here. Because having a remainder just is a natural log integral. So this last part gets way cleaner, and our answer is x cubed over 3 plus x squared plus 2x plus 5 times the natural log of x minus 1 plus c, which I probably went off the screen for you. Oh well. There's a plus c on the end. Okay, so that's a bunch of stuff. Should I start doing other questions, or should I wait on those and keep mobbing this? Any, whoops. Whoa. Any suggestions from the peanut gallery? You want to see review questions, or want me to continue on this? Do you still teach long division as well? Because the long division is easier. I wouldn't say the long division's easier. I think it's more translatable. Like, long division's more helpful in a case like this. Because synthetic doesn't work well when you have, like, some nasty bottom with no clear thing in there. So yeah, long division is definitely the play here. You don't really do synthetic division, but synthetic is crazy short if your bottom is really easily factorable. Okay, review questions is Bryn's vote. Nobody else spoke up, so that's our play. Alright, where's my review? There it is. Let's start at the first review question. Question 7 on the 3rd page. Alright, I'm not going to do the entirety of question 7 because while I showed a lot of algebra to get there, this would be a calculator allowed question. So I'll show you what I do to get up to the point where I'd use my calculator to solve this. So the first piece is to actually, for mean value theorem, you always have to do y2 minus y1 over x2 minus x1. So I need to find these parts. Because mean value theorem, if you don't remember, is average slope equals derivative. That's the mean value theorem. And so we have to find the average slope by plugging in 1 and 0 into this original function here. 1 plugged in gives us 1 plus 0, so f of 1 is 1. If I plug 0 into that original function, I get 0 plus 0 times 1, which is 0. So now that we have those, we can do y2 minus y1 over x2 minus x1. Yeah, I know this is a really boring y2 minus y1 over x2 minus x1 because it's just 1. But now, when you get to this point, what you want to do is you want to set 1 equal to the derivative of f of x, which is the function they gave us. And you can take that derivative by hand, like I did in the answers. Or on your calculator, you can actually literally on the graph type, and it has to be on the graph, not on the scratch pad, but you can literally type in d over dx, which is in that button next to 9, that little menu there in the calculus section. You can actually do this, d over dx of f of x, and you don't even need to actually take the derivative yourself. It will graph the derivative. And then once you have the derivative graphed, all you have to do is look and see where it goes through 1. So usually the way I do that is I say f2 of x by pressing tab and getting another graph equals 1, and then I look for an intersection between this derivative of f of x and 1. And that point is the point that gets us the answer. Okay. So that's the first question. I would graph this. Yeah, the algebra works out, and if you want to see it, that's in the review. But the big idea for mean value theorem, if you get a mean value theorem question, it's going to be simpler algebra-wise, and you just need to make sure you set the average slope equal to the derivative. All right, next question. 3, 6, and 10 on the second to last question. Oh, and the second to last question on the review. Okay. So, where are... Okay, 3 is this one. So 3 is just one of our classic u sub questions. If you make u equal to the exponent, which in exponentials is a really common choice, then you would get the derivative of that is 2x dx, which is really similar to 3x dx. All I have to do to get them to match is multiply both sides by 1.5. So 1.5 du equals 3x dx. If I then rewrite my integral, it's the integral from 0 to 1 of 1.5 e to the u du. You can take the 1.5 out. I've actually not even committed a foul here because I didn't talk about changing the definite integral bounds into u, but if you do 0 squared, you get 0, so my bottom bound's q for u. And if I do 1 squared, which was my top bound here, I get 1. So my bounds work for u too. All right, so then we integrate. The integral of e to the u is e to the u. There's no plus c because it's a definite integral, and then we just plug in 1 and 0. So we get 1.5e minus 1.5, which, doink, answer. Okay, next question, 6. Okay, 6 is just limit definition. You see this? This is f of x plus h minus f of x all over h, limit as h approaches 0. So you take the derivative of sine, it's cosine. You plug in pi over 3. And the cosine of pi over 3 is 1/2. Done. Limit definition, wow. Okay, 10. The reason you're probably asking about it is this is the one that's wrong on the review, not because it's a super hard question. So what I did wrong on the answer key was I didn't take the derivative, which I just did now. What you're supposed to do is take the derivative and then factor this, which factors, I believe, more nicely than the horrible monstrosity that I did wrongly there. Is that true? Nah, not really, actually. Still feels bad. So the critical points are x equals 0 and... Oh, 7's prime. That's lame. Uh, so what we have to do is x is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a, like that. And these are the other two critical points. So what is that? 3 plus root 37 over 2 and 3 minus root 37 over 2? Nick's too good at math for math club. I'm not sure that's true. I think that is false. Okay, a Karsh question is relevant to a question I just went over, which is on the mean value theorem question, how do you set the slope equal to the derivative on the graph setting? So a Karsh, the play is to, and I'll show exactly what I do. For f1 of x, I'd type in d over dx of this crap, which you can do on your calculator and you don't even have to find the derivative. If you want to find the derivative and plug that in, that's equally good. This is just really lazy. Then for f2 of x, I'd put in 1, which is the average rate of change in that question. And then all I do is I go to menu, analyze graph, and I realized in hindsight that I should have gotten like a TI Inspire app or something so I could show you. But menu, analyze graph, and then intersection. And you just look for the intersection that happens between 0 and 1. And that's the 1. So you click to the left and to the right of that. And that will get you the points. Wait, a critical point is where the graph goes through the x-axis or when the slope equals 0? Critical points when the slope... a critical point is where the slope is 0 or undefined. So, either of those. So a little more complicated than your question. Remember, where the original function goes to the x-axis are called zeros, and critical points are where the derivative goes through 0 or is undefined. All right, I'm going to pop up and look for more questions at the beginning. And the second to last question on the review. The one without a number. Okay. I'm assuming that's the one on the left here. Oh, okay. Yeah. In this question, it's a little weird. So this is a really easy function to picture. It's 2x minus 2 before 3, and then it's 2x minus 4, so it's it goes like down 2 and then starts again with the same slope. And so it's very much not continuous at 2. So there is no limit at 2. We instantly can wipe out 3. And then what these pieces are here and here are the one-sided limits. And it's saying, is the one-sided limit 2 for each of these? And heck yes, it is. And that makes both of those okay. So that's how that question works, is both of them have a slope of 2. It doesn't meet at that point, so there's no derivative at that point. It's like, is the derivative continuous? Well, the one-sided on one side it's a value, on the other side it's a value, but in between it can't be because the function's not continuous there. So the derivative is whack. Okay. Now, 46 on the second page is my next question. So that is here. Okay, all I did in 46, and this is a good question because it lets me bring this up, is pull the power out, and I get 1/2 natural log of x, and then you take the, you take the derivative, which is 1/2 times 1 over x, and then you notice that there's two little derivative marky dudes, and so we got to go again. So I don't like it in this form, 1/2 times 1 over x. So I'm going to write it as 1/2 x to the negative 1. Then I'm going to pull the power down and drop the power by 1. X to the negative 2 is 1 over x squared. So this is negative 1 over 2x squared, which is this answer. So yeah, the copy's not the highest of quality, so maybe you missed the double derivative piece there. Okay, next question. 43. Okay. Okay, so this is the slope of the line normal question. To find the slope of the line normal, you have to find the slope of the line that's tangent, because normal is always perpendicular to the tangent line. That's like the definition of normal, is you take the tangent line and you're perpendicular at that point. So you take a derivative of this garbage, which is 2 times 1 over secant x times secant x tangent x for 1 over and the chain rule part. You could also write this as secant x tangent x over secant x for du over u, or u prime over u. The secants cancel, so you just get 2 tangent of x. And then you plug in pi over 4. Tangent of pi over 4 is 1, so our slope is 2. And then you just perpendicularize it, which makes it negative 1/2. Okay. Is there a retake on the FRQ for this test? Yep. And I imagine anybody who's not awesome with their calculator is going to have to take advantage of that. All right, 42 and 2 are my next two questions, although I think I already did 2. Did I? No. Okay. 42 and 2. All right. So for 42, we're taking the derivative of a natural log. There's no powers we get to pull out, so we just have to jump straight in. We do 1 over the inside times the derivative of the inside, which would be a negative sine of pi over x. But wait, there's more, because we have to take the derivative of pi over x for our last chain. And that's kind of annoying, so I'm going to rewrite it. It's pi x to the negative 1. So the derivative is negative pi x to the negative 2. And so this mess is our derivative. Sine over cosine is tangent, so, and these negatives cancel. So I just get tangent of pi over x times pi over x squared. And so you really are just looking for this, which is e, and that gets us there. Oh, I went a little off the page. I can't type or write that high? No. I just scrolled wrong. Okay. And the next question was 2 on the review. This one's just, I think, a plugging in issue, because this is an easy integral. Negative e to the negative x is the integral of e to the negative x. You do e to the negative x over negative 1 for u substitution / undoing the chain rule. Then you just chuck in 0 and 2, and you get negative e to the negative 2 minus negative e to the 0, which is actually the negatives cancel, and I get plus 1 for that. And this is negative 1 over e squared, meaning it's 1 minus 1 over e squared, or a. Okay, I actually get to scroll down to the bottom now for a question, because I slammed through the early questions. And can you do 7 on the back side? Yes, I can do 7. I get to review the second fundamental theorem of calculus here, because that's what this is. We're taking an integral, and then we're taking a derivative of that integral, which means that we get to use our trick, the second fundamental theorem of calculus, which is we plug in 8t everywhere there's an x. And then you multiply by the derivative of 8t, which is 8. And you're good. That's it. So a lot of people forget this chain rule piece. In fact, some people retook this today, and most of them forgot the chain rule piece. So the only trick here is when you realize that it's a second fundamental theorem case, which there are some really telltale signs. First, there's a derivative of an integral. Second, there is a variable in your bounds. There is not very commonly a variable in your bounds. So, like, the last question here is also one of these because there's a variable in the bounds. Then all you do is plug in whatever that variable is, that bound, into the function and multiply by the derivative of that. All right. I'm going to do 14 on the MC. Daikун's question. The numbering on this is not logical. All right. The hint here is really good. Okay. So in this question, they give you this janky function. They say it has an inverse, and they say find the value of g prime of 6. Remember, this input into your inverse's derivative is your output. It is f of x, or f of whatever. Yeah, it's what we plug in for f of x. So that's why they give you this hint, because it just so happens that when you plug in 6, the solution for this is you just plug in 0 for x, and it makes those second two terms 0. And then 6 equals 6. So if you do that, you know x equals 0, and all you have to do for the inverse is do 1 over f prime of that x value you have to find, which in this case is 0. So I do 1 over f prime of 0. And so all I have to do now is find f prime, so I got to get rid of all this garbage I wrote up here and take a derivative. Derivative of 6 is 0, x squared is 2x, tangent has a derivative of secant squared. And then I have to do the chain rule, which in this case is much easier because the x just becomes 1, so I get a pi over 2. And then I just plug 0 into this and do 1 over it. So this is 0 if I plug in 0, but secant of 0 is 1 because cosine of 0 is 1 and 1 over 1 is 1. So actually my derivative is pi over 2 at 0. So I just do 1 over pi over 2, or 2 over pi, which is answer A. Please do 43, please. All right, that's the next destination. Wait, I did 43 earlier in the stream, Bryn. But I mean, big idea, since it's not a super long question, is you do du over u, or 1 over the inside times the derivative of the inside, which looks like this. The secants cancel. You plug in pi over 4, you get 2 for your slope, and then you perpendicularize it because it says normal. You're okay, Bryn. Don't hate on yourself. You're not dumb if you're getting a good grade in AP Calculus. Trust me. I mean, AP Calculus is not the only class I teach. I realize you guys are pretty smart kiddos. All right. To do 5, which was the question Keith asked. They're asking us to find the integral from b to a of x cubed plus f of x, and then they tell us what the integral of f of x is. But the bounds are backwards from what I'm trying to solve for, so if I swap these bounds, this is a negative 13. So right away, I can pull this out. I know it's going to be a negative 13. Which means I have to figure out the integral of from b to a of x cubed dx. But that's pretty easy. We just do x to the 4th over 4. We plug in our bounds, and we get a to the 4th over 4 minus b to the 4th over 4. And then we just attach this minus 13 guy on, and boom, answer. All right. Can you do 2? Yeah. Oh, 2 on the second page. That's a different 2. Second page. I'm going to assume it's this 2, because I don't know what second page is. Okay, so use the first derivative test to determine the local extrema of the function and identify any absolute extrema. Well, Uh, really, if you look at the multiple choice, all you have to do is decide whether or not the absolute maximum or minimum happens at 1/2 or at -1/2, and what that y value is. So that makes this quite a bit easier than those directions make this sound. So all I have to do is take the derivative, a prime b plus a b prime looks like that. And then we factor this so you can take an e to the 2x out. And if you do that, you get 1 for the first term, and your leftover in the second term is 2x. Which means, fairly obviously, we get an x equals -1/2. So, no to these ones. Then all I have to do is plug -1/2 back into the original function to find the y value, and that will tell me whether or not it's one of these or the other one, because, yeah, I mean, it has to have the right y value. So we get y equals -1/2 times e to the -1, which is y equals -1/2 times 1 over e, or -1 over 2e, which means it has to be the one that's an absolute minimum at that point, or b. Oh, cool. I did the right one, Elizabeth. That was the third page. Oh, I skipped an egg roll question. What did I do? Can you please do the bottom right box on the back page? Yeah. All right. This is another one of these second fundamental theorem of calculus questions. Because we're taking the derivative of an integral. They also give us this condition to tell us the bounds are in the right order. Sure, dude. And slash, if x is less than 0, then this is undefined because you can't plug negatives into natural logs. So basically, this condition just tells us it works for all these values. And all we do here is, since we're taking the derivative of an integral, plug in x cubed, and then multiply by the derivative of x cubed, which is 3x squared. Once you've done this, you plug into, and you should get one of these answers. We get 12 for 3x squared, and on the bottom we get 1 plus natural log of 8. Oh, sure enough. Sweet. D it is. All right. Can we go over an FRQ that will be similar to the test one? Sure. I mean, realistically, if you want to know what the FRQs look like, we did roughly 5 similar ones in class, because of the notes one and the 4, but one of them was a repeat on that homework. But I think I dug up another one that's like kind of similar. But if not, I'll just go to AP Central and find a new one. But I'm gonna go do Chinmai's now. Which is 7 and 14 on the third page. Okay, I did 14, and I did 7 already this stream, Chinmai. And 6 and 10 on the back. I also did both of those already, so you're going to have to scroll back, Chinmai. Alright, now we're going to do the free response. Let's see if this actually works. I found an old year. Where is it? There we go. It's not a calculator question, so it doesn't really fit what I want. And that was the problem we did twice in class, so new. Let's try it out here. Am I smart enough to do this? And the answer is probably not without a keyboard. Alright, let's see. Just YOLO a year and see if I can find one that's similar. That one's kind of close. Love seeing Reddit on your Google Home. Oh yeah, yeah, duh. um, cool. Particle moving to the left. Perfecto. We found one first try. All right. I'm happy to do this question. It is a no calculator question, so it's going to be a little different, but it's a particle moving back and forth question, and it's off of a fairly recent AP test, so it should be pretty close to perfect as far as these go. Will it have speed versus velocity? It definitely could, because a lot of our examples had that. So if we're looking at this question, we have a position function which has a natural log in it, so even more perfect related to this unit. And we have its velocity equation, which is, or a velocity equation for a different particle here. And it gives us an initial position only for particle q, which is the one we have the velocity equation for. So first question is, it says, when is particle p moving to the left? And so my p function is this dude. So I'm going to take the derivative of this because that's how I can tell if it's moving to the left. That's in the negative direction is to the left on a coordinate axis. So I just do u prime over u, 2t minus 2, over t squared minus 2t plus 10. And now it gets a little easier because my top is just 2 times parentheses t minus 1. So I know 1 is a critical point. On the bottom, t squared minus 2t plus 10 is not factorable. And I know it's going to fail the quadratic formula because b squared minus 4ac is like really negative. And so that's trash, and so all I have to care about is 1. So it's either before 1 or after 1 that the particle's moving to the left. If I test on either side, 0 and 2, 0 plugged into this function gives me negative 2 over a positive number, which is negative, decreasing. And 2 plugged in gives me a positive, so that is a critical point, a minimum. And when is it moving to the left? Before 1. Then it says, find all the times from 0 to 8 in which the two particles travel in the same direction. So I already know directions for, I guess this is a bad answer to 1. I forgot that 0 was the starting point. And so I actually have to say from 0 to 1. Anyways, for the second one, find when they travel in the same direction. Well, you already found all the direction stuff for particle P up here. And so now we do particle Q, which for Q, we're given a velocity equation, which I arrowed over here. So that's already a derivative. So all I have to do is factor that equation. So this is the velocity equation, if you can't see it because I wrote over it. And that factors like super nicely, t minus 5, t minus 3. Which means this guy changes at 3 and 5. I do some tests on either side with some random values. If I plug 0 into this, I get 15, which is positive. If I plug in 4, I get negative times positive, that's negative. If I put in 8, I get double positive. Okay, so we can see that it's increasing from 0 to 3, so going to the right. It's decreasing from 3 to 5, going to the left, and going to the right after 5. Our other particles only going to the left before 1, so these never go to the left at the same time. They only go to the right at the same time. Particle P goes to the right everywhere after 1. So that means from 1 to 3, whoops, t is my variable. Sloppy, Mr. Kennedy. From 1 to 3, we're going to the right in both particles. And then again, when this guy starts going from 5 to 8. Okay, 2 questions down. It says find the acceleration of particle Q at time t equals 2. So all I'd have to do in this is acceleration is the derivative of velocity. They gave me a velocity equation for Q, which was this thing. And you take the derivative of this. I'm going to solve for that pip, that possible inflection point, or the critical point of the velocity. And oh, why did I do that? Oh. So I'm supposed to find it at time 2. So I goofed up there. I don't know why I found the pip, but I didn't need it. If I plug 2 into this acceleration equation, I get 4 minus 8, which is negative 4, which is my acceleration. There are no units in this question, so just a big old box of negative 4. And then what it asks is the speed. Oh, this is a perfect question. We do get speed in here. Is the speed of particle Q increasing, decreasing, or neither at time t equals 2? And so in order to find whether or not this speed is increasing, it's basically this game. If velocity and acceleration have the same sign, then we're speeding up. If velocity and acceleration have a different sign, we're slowing down. So all I have to do is look at 2, and 2 happens before 3, so our velocity is positive. Our acceleration was negative, so we are slowing down. Even though our velocity is positive, we are slowing down because it has a different sign than our acceleration. And if you don't understand why that's the case, it really is a graphical thing. So if I pop out of this and go over here, if I have a velocity graph, this is speeding up, and this is the really obvious one. You have a positive velocity, so you're like traveling away from me, and you're traveling away from me at a faster and faster rates. But this is also speeding up, because this is like you started far away from me, and you're moving closer and closer to me at a faster and faster rate. So even though our distance is shrinking, because our velocity is negative, we're still speeding up, or this person's still speeding up and getting towards me faster. And that's why you have to do this special check. The other two cases, when you have a positive velocity but a negative acceleration like this, is my speed is decreasing. So it's like I slammed on my brakes. That's positive velocity and negative acceleration. I'm going forward, but I slam on my brakes, so I slow down and go towards 0. And same thing on the other side, same idea there. Okay, I'm going to circle back to the question and address Raquel's question, which is, for part B, why did you take the derivative of the first equation and not the second? That's because I was given in the question a position equation for P and a velocity equation for Q. So I had to take the derivative of the position equation to get that velocity equation. But for the other one, I already was given a velocity equation, so I didn't have to do any derivatives for left and right. Okay, good luck, band kids. Farthest to the left means absolute extrema, and moving to the left means relative extrema. No, Daikun, farthest to the left does mean absolute extrema, that's right. But moving to the left means increasing or decreasing. In this case, left is decreasing. Moving to the right would be increasing. So it's a little different than relative extrema. Okay, I didn't do D, which says find the position of the particle Q the first time it changes direction. So all you have to do for this is use this initial condition, which is at t equals 0. My thing started at 5, so I got to start with 5. And then I got to integrate from here until the first time it changed direction. Oh no, I got rid of all my work. Feels bad. So what was this? T minus 3, T minus 5 when it factored. So 3 was the point at which it first changed direction. Because my two critical points, i.e. the change in direction points, were 3 and 5. So the first one's 3. So those are my bounds on my integral, and I'm integrating t squared minus 8t plus 15 dt. And on our question that you'll see tomorrow, you're going to be given something you probably don't know how to integrate here, or that would be time consuming to integrate, and you'll just slam this on your calculator or just write an integral depending on what I ask you to do. But on this question, they actually wanted the kiddos to solve it, so I'll solve it. Again, you get a calculator question tomorrow for your free response. So this is the antiderivative, just raising all the powers by 1 and dividing by the new power. And then you plug in 3 and 0. 0 plugged in gives you 0, so it's really just plug in 3. You get what? 5 plus 9 minus 36. Whoa. Plus 45. Okay. So it's 5 plus 9, which is 23. And that's the position the first time it changes direction, which is pretty cool. We also can idiot check this, and if you remember earlier, we were increasing before 3, decreasing between 3 and 5, and then increasing after 5. So we should have, from our initial condition 5, gone up. And we did, because we ended up at 23. So idiot check checks out. We went up, and we went to a higher value. So that works. Whew, that was a lot of talking. Also, Daikun said you can, or who said this? I want to give credit where credit is due. Oh yeah, you can go to past AP questions, and there are always questions like this. That's part of the reason why these are the free response I want to test this year, is because I really want people to have access, or to have practiced really likely AP questions. And these really do show up almost every year. These particles moving left to right, and often they have exponentials and logs in them, which is why I use them for this section. And again, you'll get your calculator on the test tomorrow, so make sure you know how to plug in integrals. Make sure you know how to graph derivatives and realize that the calculator can't actually take a derivative for you. But what the calculator can do, so I'll just riff right now since I don't have any recent questions, is you can graph d over dx of any function, and it will graph it for you. You can integrate a definite integral on your calculator, and it will give you the answer. You can also do menu on the scratchpad, menu, calculus, and numerical. Whoops. Oh, poop. You can do numerical derivative at a point. This is a really nice tool because this can help you find any, like f prime of 4. Again, this is in menu, calculus, since I deleted the page, and then numerical derivative at a point. You can find f prime of 4 of some janky function really easily with this tool. You have to navigate some menus, and usually they ask for the point first, so you gotta say it's 4. You gotta say, hey, the variable I want to look at is x. Those are the two necessary parts that you gotta fill in the dropdown. And then it'll dump something on your page that looks a little something like this. And then it'll ask you to put something in here, and it'll have that kind of stuff. And all you have to do is dump your function in there, and it will solve it for you. So that's pretty useful. And those are the kind of the big three. Otherwise, really, the stuff in menu, analyze graph, is super helpful. Just all the things in there are very descriptive and tell you what they do. You know, zeros, intersections, all those sort of things. That's a really, really useful section. Were there any other mistakes on the answer key? Not that I know of. I don't think so. I just went over like half the answer key, so if I got the same answer as the answer key, then I think we're good. And yes, no raiders this time for the live stream, so good on Liam. Ramik's not a bad guy. It's not his fault Doji came entirely. Uh, he's a good dude. The other guys, not so much. um, any questions before I peace out? I slammed through a bunch of stuff. Oh, and the only reason there wasn't a retake on the final FRQ is because grades are due, and I don't want to go back and change everybody's grades individually because that's a real pain in the bottom. Only do that for special circumstances. Are there going to be problems from previous tests on this test? Not exactly, but absolutely. Like, stuff like the second fundamental theorem or limit definition or related rates or any of those like really important concepts are always show up. Not always, but like are on every other test after their unit. Although limit definition might be every test. So always make sure you know limit definition. It's on all our reviews as well. Is there any inverse trig for the tests? Yes, there is inverse trig on the tests. I can tell you the inverse trig question is not hard. If you know the basics of inverse trig and the basic forms of how they look, you're chilling. That's enough. And good enough to get what you need done. There's not much inverse trig. Like, the minor stuff on this, which there's maybe one or two questions of each, is like inverse functions, inverse trig. These are small sections that really don't show up a ton on the AP tests. Logarithmic differentiation. Long division. These are what I call, or synthetic division. These are the small things. These are like maybe one question, maybe two. But the other things in the unit, like natural logs, exponentials, those sort of things, are like mad. I way more heavily skew towards those sort of questions. Is it an inverse trig integral or derivative equation? It could be either. They're roughly the same in look. Because, I mean, if you integrate 1 over the square root of 1 minus x squared, that's inverse sine plus e. And alternately, if you take the derivative of arc sine, you get 1 plus root 1 minus x squared. So realistically, you're studying the same thing either direction. So yeah, I'm not going to divulge which direction it is. But it could be either, and it's not going to be a ton harder than what I just did here. If you know the rules, you're going to get it right. Even if you know the rules, like, in a very basic sense, you're going to get it right. Face reveal. I mean, come into my class tomorrow. That's my face reveal. It's not like I'm a secret figure here. Way too lazy to turn on my webcam or anything like that. All right. No problem on the live stream thing. I will post this when it posts, so like in an hour or so. And thank you for showing up. I got really good questions this time. I was like cruising for like maybe half hour, 40 minutes, like running myself hoarse because you were giving me good questions. So I really appreciate the involvement this time around. And I hope you have a wonderful night. Later, guys.